Here we go. We're keeping on, and tonight we're going to be talking about the teleological argument, and we're starting that tonight, and that will probably take about 3 or 4 sessions total. It is one of the topics that's near and dear to my heart because it has to do a lot with science, and as you guys know, I love science. I was a chemistry major, and obviously I'm into the science of medicine now. So tonight we're going to be talking about the universe predominantly, and then in the coming weeks we're going to talk about Earth and our solar system and our galaxy particularly. Then we're going to talk about the origins of life and what life means and the complexity of life. And then we're going to talk about DNA and evolution. The last two we may end up covering together. It just kind of depends on how long it's going to take us, because I don't want us to rush through this, because we talked in the beginning about the fact that one of the things I want you guys to be able to do is to talk to someone who says, all right, I'll let you talk to me about God or why God exists, but I'm not going to let you use the Bible, because that's begging the question. It's not begging the question, but they'll oftentimes say that. And so I want to be able to offer you the opportunity to be able to speak on these topics, and many of these are scientific topics. Just as a reminder, back several sessions ago, we talked about the difference between deductive and inductive arguments. So in the teleological argument, we're going to be talking about inductive arguments. So it's arguments that are based on the accumulation of data or evidence. Remember, a deductive argument is one in which if the premises are true and follow from each other, that the conclusion is true, absolutely, right? Socrates is a man, or all men are mortal, Socrates is a man, therefore Socrates is mortal. That's a deductive argument. If the premises are true, you can't argue with the conclusion as long as it follows. These are not, so when we deal especially with the teleological argument, we are dealing with the inference to the best explanation. So, in addition to the teleological argument, one of the ones that we'll talk about later is called the minimal facts argument for the resurrection of Jesus. But it's specifically a type of argument called an argument from analogy. Okay, the one I like to use oftentimes is a watchmaker and a watch. Right? When we see the complexity of a watch, if you look at a watch that has an open face to it and you see the gears turning in there, you know intuitively that watch had a watchmaker. And an argument from analogy is if you see that same type of specified complexity in anything else, like an iPhone or a car, you know that those things were designed by an intelligent designer. And that's really what we're going to be talking about with the teleological argument. When you see the amount of specified complexity in the universe and in life and in our planet, you're going to see why the argument from analogy holds so true. That the universe, at least in my mind, had to have had a creator. Okay? So that's what we're going to be talking about tonight. And remember, we got to go back to this every single topic. All beliefs begin with a claim. In our case, the claim is God exists, right? We've got many Bible verses that say that, but what we're trying to show is reasons that we believe God exists. And of course, we call these theistic arguments or arguments for the existence of God. And again, we're going to be talking tonight and for the next several sessions about the teleological argument for God's existence. So, I know this is one of your study questions. I often actually write those several weeks in advance, so usually I don't remember what they are. But one of them tonight is, what does the word telos mean? Well, telos is Greek, and it means goal or purpose. So it's the argument from design. Okay? It's oftentimes now called the argument from design. But again, in a similar fashion to how the cosmological argument worked, where there's actually multiple ones, I think that in this case, in my way of looking at it is, when you look at the argument from design, there's the argument from, the original one was the argument from design of the universe. And that's what we'll go over tonight. But I think there's actually argument from design of our planet, argument from design of the origins of life, and then argument from design to show that in reality there's less evidence for macroevolution than there was when Darwin first proposed the theory. So we'll talk about each of those separately. And we know from Romans that we've shared this during the cosmological argument as well, that what can be known about God is plain to them because God has shown it to them, for his invisible attributes, namely his eternal power and divine nature, have been clearly perceived ever since the creation of the world and the things that have been made, so that they are without an excuse. And of course, in Romans, Paul goes on to say that in reality, people know that there's a God, but they reject the truth. So the fine-tuning argument goes something like this, or the teleological argument. It says the fine-tuning is the result of necessity, chance, or design. If you stop and think about it, in any object, whether we're talking something small like the bottle of water sitting on the table or the universe, that's really the only three options. I can't, and philosophers long before me have never been able to come up with any other than those three. Right? It's either just chance, just happens to be, or it had to be that way, it came out of necessity, or it was designed, right? And what we're going to say is they are not the result of chance or necessity. Therefore, they're the result of design, therefore, there's a designer. Okay? And again, and this is somewhat for the people that will be watching, the atheists that will be watching the video afterwards, because yes, we've been getting a lot of comments about it. No, this argument is not an argument that gets you to the Christian God. It's not meant to. Remember, we're doing a two-step apologetic where first we convince the atheist that there is a God, and then we convince the atheist that the Christian God is the correct God to worship. So again, teleological arguments really start from the universe and then narrow down, right, to the privileged planet, to life, to single-cell organisms, and most importantly, honestly, the thing that has really, in science, been a big hit against Darwinian evolution is the micro-machines that have been discovered within the cell, like the flagellum that you see up there. But tonight we're going to be talking predominantly about the universe. Now, before we do that, because I'm going to throw some crazy numbers and powers at you, I just want to give you a practical understanding of some math, because the math, honestly, is going to get so ridiculous that you and I cannot fathom the amount of math we're talking about, okay? If Alan here asked you, Tony, to marry him, and you said, give me $1,000. Yes. But if Tony had said to Alan, give me 1,000 seconds, okay? 1,000 seconds, if you remember, that's 10 to the third power, okay? 1,000 seconds is 16 minutes and 40 seconds. Not that long. So Alan would say, okay, seems reasonable, right? Well, what about if Tony said, give me 1,000,000 seconds? 1,000,000 is 10 to the sixth. So if you're talking about the chance of 1 in 10 to the sixth, that would be 1 in 1,000,000th, right? 1,000,000 seconds takes 11 days, 13 hours, 46 minutes, and 40 seconds. Again, not that unreasonable, right? Especially if you're trying to decide to marry Alan. But what about 1,000,000,000? What about 1,000,000,000, right? You've only gone up 3 powers, right? You went from 10 to the 6th to 10 to the 9th. 1,000,000,000 seconds is over 31 and a half years. Now, to give you a modern day example of this, when we start talking about a trillion, the proposed budget, 3.5 trillion, if you paid it back at $1 per second, it would take you it would take you 31,688 years to pay it off if you paid $1 a day into a trillion. A trillion. And that's 10 to the 12th. Keep that number in mind. 10 to the 12th. 1 trillion. 10 to the 12th. Because the numbers we're about to talk about far exceed that. Okay? To give you an idea, the human body has about 10 to the 14th cells in it. So that's 100 trillion. About 100 trillion cells. Okay? And not too long, the deficit is going to be about 100 trillion. But 100 trillion cells. Our bodies, an adult body has about 10 to the 14th number of cells. Okay? There is estimated about 10 to the 80th power of subatomic particles in the universe. Okay? Just keep those two things in mind. And now we're going to start talking about where that comes into play in the universe, and specifically in the beginning of the universe. Fred Hoyle, who's one of the guys we talked about last week, who actually argued against the beginning of the universe. Why? Because he had a theological, philosophical reason to argue against it, because he wanted a steady state universe, because he understood that if there's a beginning of the universe, there's a beginner. And so even Fred Hoyle, who ultimately became a deist, said a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as chemistry and biology, and that there are no blind forces worth speaking about in nature. Okay? So when you talk about the universe, there are four fundamental forces that you have to understand when we talk about these. One is gravity, and specifically something called the gravitational constant. Now, I'm not talking about, we all learn in school, gravity is 9.8 meters per second squared, right? That's actually the acceleration of gravity, but we're here talking about the gravitational constant, okay, which is true between any objects, between me and Amp, between Amp and his bottle of water, everything. The electromagnetic force, and then the strong and weak nuclear forces, okay? So, just four things. Seems pretty simple. Should be able to dial that in pretty easy, right? Understand that if the ratio of gravitational force to the electromagnetic force were changed by 1 part in 10 to the 40th, stop and think again, 10 to the 14th is how many cells we have in our body. 10 to the 80th is how many particles are in the universe. If that ratio were changed by 1 part in 10 to the 40th, that's the number. I don't even know, there probably is a name for that. I don't know what it is, but that's the number. It's an incredible number. To give you an idea how big that is, if you took a Susan B. Anthony dollar and you took North America, all of North America, and you started covering the surface area of North America with Susan B. Anthony dollars, you would have to stack them all the way to the moon. So 1 chance in 10 to the 40th would be this. If you painted one Susan B. Anthony dollar and you put it in that stack and you made that entire stack covering North America to go to the moon, and you put little Susie, and you took a blindfold and put it on little Susie, and you asked her to pick out that red coin blindfolded, her chance of picking out that one red Susan B. Anthony dollar stacked to the moon, covering all of North America, is 1 chance in 10 to the 40th power. That's just one ratio. The ratio of gravity to the electromagnetic force. That is the number that you're talking about. Okay? That alone is enough to make me say, there's a God. Okay? So, if that ratio were changed by 1 part in 10 to the 40th, which we just saw how enormous that is, no large or small stars would exist. If the ratio was changed one way, everything would implode in on itself and no stars would be made. If it was changed in the other way, the ratio was changed in the other way, all of the particles of the universe after the beginning would have spread apart too quickly and no stars would have formed. Either way, you wouldn't have stars. If you don't have stars, you don't have life. If you don't have life, we're not sitting here talking about this. 1 part in 10 to the 40th. That's just one ratio. What about the gravitational constant itself? That's actually the numerical value for the gravitational constant. Now, if you recall from last week, Einstein fudged this. He fudged this number, and he later said it was the biggest mistake of his entire scientific career. The reason he fudged it is because when he was actually doing the calculations, he realized that his theory of general relativity predicted an expanding world. And he understood that if it was expanding, it had to have expanded from something and therefore had a beginning. Well, he too believed that the world was static, so he fudged the number. Later, this number was calculated because of other measurements that were able to be taken. Okay? So that's the gravitational constant. If it were varied by just 1 part in 10 to the 60th parts, 1 part in 10 to the 60th is that. It's something like a million, trillion parts. If it were changed by 1 part in 10 to the 60th, there would be no universe as we know it. Again, if it were 1 part in 10 to the 60th larger, the entire universe within 1 second after being begun would have collapsed on itself because the gravitational constant would have been too high and all the matter would have collapsed down and would have imploded. If you vary it in 1 part in 10 to the 60th part lower, everything simply scatters because none of the particles would have actually coalesced to form stars and planets and universes and all of those kinds of things. 1 part in 10 to the 60th power. Life wouldn't exist. Now, what about the expansion rate? We've talked about the fact that the universe is expanding. There's essentially zero doubt about that. Even Alexander Vilenkin, who himself is an atheist, says that the universe is expanding. In fact, the Born-Guth-Vilenkin theorem says that in reality, it can't ever shrink back down, really. There's another constant in there, and that is this one. It is called the cosmological constant. And the symbol for it is lambda. If lambda changed by 1 part in 10 to the 120th power, remember, it's only estimated that there are 10 to the 80th power particles, subatomic particles like protons and neutrons in the existing universe. If that cosmological constant varied by 1 part in 10 to the 120th, the universe as we know it would not exist. Stephen Hawking himself, no theist by the way, says if the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, the universe would have recollapsed before it ever reached its present size. Lee Smolin put it gently when he said, perhaps before going further, we should ask how probable is it that a universe created by randomly choosing the parameters will contain stars? The answer to that in round numbers comes to about 1 chance in 10 to the 229th power. 1 part in 10 to the 229th power. That's meaning if you were to walk into a control station and all of those constants were there, you would have to dial each one of them into that amount of exact precision, or stars wouldn't exist. That is 1 part in 10 to the 229th power. I would argue even Joe Biden couldn't understand that amount of money. Don't know why I did that. Think of it this way. This is how incredible that is, right? That all those things have to be dialed in order to even get stars. 1 part in 10 to the 229th. To give you an idea of how big that is, if you took all the protons in the known observable universe and you randomly dialed those, remember, we're walking into a control room, we start dialing those dials in. Gravitational constant, cosmological constant, weak nuclear force, strong nuclear force. There's others, but those are the main 4. We start dialing them in randomly, differently, for each proton in the universe. But let's say each of those protons is a different universe. If you took all the protons in the universe and randomly assigned them those numbers, there would not be a universe that contains stars statistically. Think about that for a minute. We can't even fathom that kind of math. You can't fathom it. We can barely fathom that our bodies contain 10 to the 14th power of cells. Cells, right? These are protons. You took all the protons and made each a universe. None of them statistically would contain stars, but ours does. Ours does. Paul Davies, who's a world-renowned physicist, says, the cliche that life is balanced on a knife's edge is a staggering understatement in this case. No knife in the universe could have an edge that fine. So that brings us back to our original article, or our original argument. And the argument is this: the fine-tuning is the result of either necessity, chance, or design. Again, nobody's going to argue that with you. Now, I don't know anyone who would really argue that it had to be that way. Now, there is one objection that sort of goes to that. Some atheists will say, well, the only reason that we know this is because we're here. So by definition, because we're here, it had to be that way. The problem is that circular reasoning. Right? The only way that you get to that conclusion is by starting with that conclusion. Right? Because obviously if we weren't here, we wouldn't be thinking about this. Okay? So it's not really due to necessity. That we can, anybody, remember what how we defined a necessary thing or a necessary being in modal logic? It's something that has to be that way in all possible worlds. Right? Or cannot be another way in all possible worlds. You cannot have a married bachelor. By definition, if you have bachelors in all possible worlds, they are all unmarried. It's a definitional thing, right? We can imagine a universe that's just a plasma field, or only has one star. In fact, mathematically, it's actually more likely that the universe would have evolved with a very small package of like one star and a small solar system, not the vast universe that we see and observe. So I would argue it's not from necessity. Now, the probability that the universe occurred randomly, i.e. no conscious creator involved, is 1 part in 10 to the 10 to the 123rd power. That's far larger than that 10 to the 229th power. Far larger. I can't even none of us can wrap our minds around that number. And Roger Penrose said that a number which it would be impossible to write out in the usual decimal way. You could not write that out in the decimal way. Because even if you were able to put a zero on every particle in the universe, there would not even be enough particles to do the job. That's how big that number is. Now, atheists would say, as they did in Dumb and Dumber, so you're telling me there's still a chance? The answer is no. No, right? Remember, this is an argument, and all inductive arguments are arguments to the best explanation. Quite frankly, in a philosophical manner, to quote, win an inductive argument over an opponent that you happen to be debating, you only have to show a 51% likelihood that your argument is correct over theirs. Our argument is 1 part in 10 to the 10 to the 123rd. That's the chance that it's randomly chanced. Okay? So that leaves us with design. Now, as we said, they're not the result of chance or necessity. Therefore, the data are a result of design. Therefore, there is a designer. And then that will stop because it gets even more complex when we start talking about our galaxy, the Milky Way, our solar system, and our planet and water. believe it or not. Water is perhaps one of the most amazing things that most all of us have never even thought about, that actually defies a lot of the other chemical things that we observe in nature and in the universe that, of course, we all know you have to have in order to have life. That's why it was such an amazing finding to scientists when they found water, the evidence of frozen water on Mars. So we'll stop a little early tonight and entertain questions.
So the 4 parts you're talking about as far as creation, is that like a solid core become
Oh no, there are many other constants. Those are just what they call the 4 main cosmological forces and those are the ones that have to be fine-tuned more than any of the others. There's actually a lot more than that, but those are the 4 that really, really have to be fine-tuned in order to even honestly have an observable universe. Yes?
Now, he was talking about the breaking down of the atom.
Yes.
And that was what really triggered it in his mind. Can you understand kind of what he was talking about with protons and neutrons?
Yeah, I'm trying to remember exactly which way he looked at it, but when you look at, perhaps the easiest way for me to answer is this. When you look at the way and this is a very simplified way of looking at it because honestly it gets exceedingly technical, really beyond even what I understand, even as a chemist. In the shortest portion of time, right after the initial conditions of the universe, the initial bringing into existence of the universe. I hate using the term Big Bang. I'll use it sometimes just because everybody understands that means the beginning of the universe. But and you're literally talking about like 10 to the negative 35th to 10 to the negative 42nd seconds after the initial conditions. There were exceedingly tight conditions there that had to be that way in order for us to get both light and heavy elements. If it were tipped in one direction, basically the universe would be nothing but helium. If it were tipped in the other direction, it would be essentially nothing but heavy elements like uranium, plutonium, things of that sort. And in fact, that's a lot of the technicality that comes into the type of star we have. In order to have life, you have to have a star that is they call it in the Goldilocks zone. It's not too old, not too young, not too big, not too small. Because if it were too old, it would be burning too hot. If it was too young, it would be too cold, and all the water on Earth would be frozen. If it were too young, it would be too hot. If it was too big, it'd be too hot. If it was too small, it'd be too cold. So, if I recall correctly, I believe he was talking about what it had, like the conditions that had to come together in order for us to even have elements other than just helium. And he looked at that, and he looked at the balance that was needed for that, and said, oh my gosh, this is phenomenal. The other thing I will add to that is if you look at the amount of energy that comes out of fusion or fission, right? So atomic bombs are, do you remember? Yep, but what are they doing? Splitting the atom apart. Yep, so that's fusion, right? Fission. So the amount of energy that comes from breaking apart the nucleus of just a small amount of nuclear material. It's really not very much that's in an atomic bomb. Like the atomic bomb that destroyed Nagasaki and Hiroshima, they're not that big at all. But the reason that they work is because the amount of energy stored in the nucleus of an atom is so immense that when you release that energy by basically popping the nucleus in two, is enough to literally vaporize cities. And I think he also mentioned that in his book as well, if I'm not mistaken.
You call the 3 parts and kind of related to Trinity as
That's right. Yeah, but I don't remember what his argument was there. Yeah, the electron, neutron, and proton.
As long as you believe
Yeah,
in
yeah.
both of them, all of them. But he could see evidence of the Trinity from the smallest element.
Elements of the yeah. It's been a long time since I've read the book, but now that you say that, I remember him saying it. I don't remember his exact argument there, but it is pretty amazing actually that neutrons and protons have essentially the same weight, but yet one's charged, one's not charged. And then you have electrons, which have a negative charge, which are far smaller than either protons or neutrons. And there is a very fine balance there, actually. I don't remember the math behind that one, but there's an extreme balance there with if the conditions weren't quite right, you would have nothing but neutrons and no protons. And I don't remember exactly what that balance is right off the top of my head. These numbers are pretty staggering, so to remember them all is a little tough. All right. Any other questions?
Just out of curiosity, I saw this the other night, I don't know if you heard it or not, is the Big Bang was caused by a sound wave. Have you ever heard of that?
That is, no, I haven't, but that is one of the most ludicrous concepts on, I've heard a lot of ludicrous concepts. As an otolaryngologist who deals with audiology and sound, that's maybe the stupidest thing I've ever heard in my life.
What caused the sound?
Well,
Right.
that was, I mean, they were doing on Science Channel, one of those channels, and my first thought was, you're right, God spoke.
Yeah. Yes, yeah. But you see, in order to have a sound wave, you have to have a medium to go through, right? People don't realize that, in fact, sound actually travels faster through solids. Remember when you were a kid, you thought you heard, well, around here, most city slickers would never know what we're talking about, but around here, you know, if you were walking down the tracks and you thought you heard a train, what would you do? You stick your ear up against the track. Why? The particles are closer together. So sound waves are not sinusoidal waves. Sound waves are, they look more like an accordion. They're a compressive wave, right? So it actually takes longer for sound to get from, say, me to amp in air because the particles are further apart. So you have to bounce them further. Well, if you don't have a medium, how do you have a sound wave? That's even dumber than asking the question if a tree falls in the woods and no one's there to hear it, is there a sound?
I ran with it. I found logic in that.
I like your answer. I like your answer because that's the only legitimate answer you could have given to that question. Or to that.
There's your sound wave.
My goodness. A sound wave brought the. Yep. You're right. And God said, let there be light. Goodness gracious. Yep. We hope that you enjoyed the content of our video today. If you did, make sure to give us a thumbs up and share this content. Also, don't forget to hit the subscribe button and hit the bell so that you are alerted to any new content that we post on our channel. Please remember that all of our video content is completely free of charge and can be reposted, shared, and embedded. You can also find us on Facebook at facebook.com/armorofgodapologetics with an S. Thank you for watching and have a blessed day.